And I mean, we've vertically integrated the manufacturing of the heat shield tiles because there was no supplier that could provide us with the materials that were needed. So the you need to make essentially this very fine vermicelli of glass and aluminum oxide fibers. Aluminum oxide is basically sapphire. So it's like glass and sapphire, very fine fibers in exactly the right geometry with special coatings in order to have this heat shield tile be reusable, like not melt, but not be so brittle that it gets damaged on ascent or descent. Like it can't be as, it's kind of like almost the brittleness of a coffee cup type of thing. And the rocket's shaking like hell. So you got this thing like, you saw it firsthand. Like imagine you're at ground zero of that rocket. Like you feel how much shaking it was when you're like 5 miles away. Imagine if you're right there, So you're shaking these things that are like as brittle as a coffee cup, trying not to have them crack or break. And then not have them melt. You've got several thousand of these things. And if even a few of them break, it's not reusable.
So is there innovation that's being done in the materials technology at SpaceX where you're constantly trying to find and tweak a better version of this?
Yes. It's a very difficult problem. It's a problem no one has ever solved. So we've got to get the exact right materials combination, the right molecules in the right shape, and then apply that heat shield perfectly to the rocket with no mistakes. There's a reason that no one solved this before. It's a very difficult problem. So, like I said, we've had to vertically integrate the entire manufacturing of the tile from basic raw materials to a finished tile. Build the entire supply chain from basic raw materials. So you're just inputting silicon and aluminum oxides.